It's time to get restarted here, and I think we rushed through lunch a little bit, but we have some very interesting topics to review today. We've heard a lot of science. First, my name's Joe Newsom at the University of Pittsburgh, and we've heard a lot of science the last day and a half, and we have a little bit of science that's coming, but our focus for this session really is to get into a little bit of the nuts and bolts on how you establish and how you maintain the facilities and the infrastructure that you need, and how you might get buy-in at your institution to assure that the resources are needed so that you can do successful microbiome research. So that's our real intent of this session, and I'd like to start off by introducing Dr. Tim Hand, and he's a young investigator at the University of Pittsburgh, and he's been working with me to convince the leadership what we might need to do to make this functional and run full steam ahead so that we can get some really good science done using these models. Tim?
Thanks, Joe. You guys hear me? I'm good? All right, so thanks to Joe and thanks to the organizers for giving me this opportunity. As he mentioned, I'm a recent transplant to Pittsburgh. I've been there. This is a picture of, as I call it, America's most livable city. It really is a great place, and we'll talk about that a little bit at the end. So I'm really not going to talk a lot about science today for the main reason that this is a talk about establishing a gnotobiotic facility, and I actually think everyone who's gone before me has done a great job putting their science into the context of what they were tasked with talking about. But since Pittsburgh does not yet have a gnotobiotic facility, I don't have any data from said facility to show to you guys. But I will give you an idea of what we're doing in the lab, just so you guys can understand sort of why we're so interested in building a gnotobiotic facility. So what our lab really focuses on is right here, which is T and B cell responses against the commensal microbiota. So actually, in a term that was actually coined by one of our earlier speakers, Andrew McPherson, we're very interested in this idea of the mucosal firewall. That is the idea that intestinal immune homeostasis is maintained as a combinatorial effect of both the physical barrier being presented by the intestine, which is made up by the epithelia and the tight junctions, the mucus layer, and also antimicrobial peptides that largely keep the bacteria away from the surface of the intestine. But we know that this system is not completely able to keep bacteria and bacterial products and metabolites from coming across. So there has to be another system, and we call this sort of the active barrier. And this is made up by dendritic cells, T regulatory cells, and IgA-positive B cells. And actually something we really haven't touched on at all in the meeting, and something I always like to bring up when we talk about the intestinal microbiota, is that these T and B cells have a unique set of genetics that aren't encapsulated in your germline. Right? These T and B cells, they make unique joints as a result of VDJ recombination, and in the case of B cells, they actually then mutate even more due to somatic hypermutation. So even though each of our individual mice have been inbred 40 or 50 times to be genetically identical, we know this from actual experiments, their T and B cell repertoire is actually unique. So when I was looking at Jay Faith's amazing talk earlier this morning, you guys maybe noticed that he was seeing quite a bit of variability in what was a very well-controlled system. You know, he was giving the exact same bacteria to each of his mice. Those mice were genetically either identical or very, very similar, and yet he was seeing 5 or 6% difference in their Th17 response. I might argue that some amount of that difference in the Th17 response or in the IgA response or any of these responses is due to individual variability associated with VDJ recombination and somatic hypermutation. And this is exactly what I want to have a germ-free facility to look at. So we know that those T and B cells, and we know that the immune system, particularly in the GI tract, is particularly important because we know what happens when it goes wrong. So this is a non-comprehensive list of diseases that we really still are working on producing cures for. And basically, each one of these diseases is characterized by a significant shift in the microbiota, which is correlated with a very significant increase in the sort of inflammatory character or immune cell activation at that site. And we would argue, and I think Skip Virgin did a brilliant job introducing this, that one of the most important perturbations, one of the most important shifts that can happen in this relationship between the immune system and the microbiota is actually infection. So we've now shown in work I did just up like about 10 miles up the street here at the NIH in the laboratory of Yasmin Belkaid, we showed in 3 papers that GI infection can cause very significant and very critical shifts in the microbiota that are associated with huge increases in inflammation. We then went on to show that infections can damage the lymphatic system, and this leads to problems in terms of processing information by the dendritic cells, i.e. the dendritic cells and monocytes and macrophages no longer traffic into the mesenteric lymph nodes. They now traffic into the adipose tissue, which leads to long-term low-grade inflammation. And then we also showed that during infection, really the lines between what we would call a pathogen and what we would call commensal get enormously blurred. And so the immune system is unable to discriminate these two things. And in fact, we would argue now in later data that as I mentioned, we're not really going to get into, that there is no discrimination between commensal and pathogen. The immune system just sees microbes. And these definitions which we've put on these organisms really don't have much to do with their biology per se, and maybe have more to do with how they've traditionally interacted with one host, that would be people. But so that just gives you a lead into why I'm so interested in establishing a gnotobiotic community. So what we're going to talk about today is the three steps we've been taking. One of the biggest ones we've been taking is education and training within the PIT community. We'll talk a little bit about specific steps about what is the equipment and what is the setup of the rooms that we're going to be doing our work in. And finally, we're going to talk a little bit about building a gnotobiotics infrastructure. So it's not enough just to have germ-free mice and to just be able to do these very carefully beautiful experiments, but you also have to have an infrastructure around that so that you can actually assay these things in a controlled way. So first was education, and this is probably the most important slide, and this is most where I've spent most of my work. And really, this is education towards the administration. This is people who have positions that are much more important than my position. So it's been critical at Pitt to get buy-in from the senior administration, because this is going to provide us with the funds to start up our facility. Unfortunately, at Pitt, we do not have a room that is set up and ready to go for this, so we're going to have to spend a significant amount of money renovating a room. And we'll talk about that a little bit. And for that, we needed money from the senior administration. And also, I know in particular from the facility that I worked in at the NIH with Dr. Belkaid, by the way, if the people who are here, particularly Dr. Starter, who has a lot more experience, if I say something completely wrong, you can correct me. But my understanding in Yasmin's facility was that the most important recurring cost in the facility is staff. And that's what you need the subsidy the most. This staff is critical. We're going to talk about that a little bit. And the staff is really the only way to success within a gnotobiotic facility. So we've made a strong case for the benefits of the facility, essentially arguing that the costs are relatively large, but it's the only way to control costs. Having investigators purchase mice from Taconic on a regular basis to do their germ-free experiments is not renewable. I just looked up this morning. The average cost of a Taconic germ-free mouse at 3 weeks of age is almost $500 with shipping. So this is not something that any lab can do on a recurring basis. That would mean an experiment of 10 mice is going to set you back $5,000 before you've done anything to the mice. So we need to be able to breed mice in-house in order to do these studies in a cost-controlled manner. We've needed to be clear with the administration about the necessity for a point of contact facility. It's been brought up a number of times with meetings that I've had about the idea that we would be able to contract this work out or send it out to other universities. I don't think that is a sustainable project. You need to be able to get your hands on the mice. You need to be able to do experiments in real time. You can't have a lag. And I actually, I can't speak to MTA processes at other universities, but each of these collaborations and contracts would require a lengthy MTA. So every time you want to change an experiment, it's gonna slow everything down. And finally, one thing that's been very successful for us is we've been trying to fit our gnotobiotics program into the framework of microbiome and metagenomics effort, which has had a tremendous amount of support from the administration. And so this is where we've really made our case and made it stick. So we've also done a lot of PIT community outreach. And this is tremendously important. I mean, I think most of the people here are familiar now, of course, I guess if you've been here the last few days, what gnotobiotic animals are. But this has been important for us. It was surprising for me, someone coming from a very microbiota-focused lab, how much this sort of needed to be done. One of the big things we had to educate on is essentially gnotobiotic animals. When we first discussed building this facility at Pitt, there was a lot of excitement. And the first discussion was people said, oh, I have a knockout mouse. When can we make it germ-free? How much antibiotics do I need? These are the actual questions, and you have to educate on the re-derivation process, on the cost associated with it, and the difficulties with raising and keeping the mice for long periods of time. And implicit in that conversation is a conversation about what are the advantages and limitations of these animals. What are things that you can and cannot do with a germ-free animal? So one of the big interests at Pitt, just to pat ourselves in the back, we are a big transplant facility. So there's a lot of interest in looking at the role of the microbiota in transplant rejection. This is not a typical germ-free isolator experiment. We think it's something we're going to be able to eventually to work up to doing, but it's something that's going to require some work. Without discussing the nuts and bolts and the technical issues associated with a gnotobiotic isolator, you can't really explain to someone who's a transplant immunologist what's going to be difficult about transplanting hearts onto the aorta of a germ-free mouse. So this is tremendously important. And so that fits into how we carry out the experiments, and how does that affect your experimental design. And this education effort was also great because in part it was an ad hoc recruitment effort, because we do need a subsidy from the university, but we also need people to use the facility. So we need to get people thinking about how can you use gnotobiotic animals, how can you associate mice, either use them germ-free or associate mice with specific microbiomes, and use that to really push your science forward. So with that effort, we've carried out now one, and now we're going to soon have another microbiome symposia. It was a full-day symposia. It involved a lot of people actually in this room. It had the double effect both of doing the education, which we talked about in the previous slide, but also discovering people's needs in the facility, which was tremendously important. We're soon going to have a boot camp on the microbiome, which will be in the new year, to get people really up to speed and get them to understand what kind of facilities we have at Pitt, and we're going to be building at Pitt. But really what I wanted to talk about here is the importance of this education effort, because for those of you who are thinking about building up a new gnotobiotic facility, or even just increasing interest in your gnotobiotic facility, the real benefit for us was to learn what people wanted to do. And at least I learned was that, at least at Pitt, the intestinal microbiome is not really that interesting to people. I mean, it is interesting, but only in the sense, we have a much stronger interest in pulmonary medicine at Pitt than we do intestinal medicine. There are great people doing the intestine at Pitt, but there's a lot more on pulmonary. So, we had a lot of people interested in the pulmonary microbiome. We had a lot of people interested in the relationship of the microbiome to cancer therapies. So, and we have a lot of interest in doing metagenomics and not as much interest in doing 16S. We have a lot of people interested in looking at mutations, like what Dr. McPherson was showing earlier today, mutations in defined communities going forward. So what this tells me is that in our animal facility, it's not going to make a tremendous amount of sense to invest in short-term quick isolators, because these experiments on COPD, or experiments on the mutational rate of a defined microbiota, these aren't things you can carry out in a week in an out-of-isolator experiment. We're going to need long-term housing, and of course, to do pulmonary stuff, we're going to need the ability to do BSL-2+ or even higher pathogens. So now we're going to go into the nuts and bolts about how I've been working with others, including Joe, to try to build a facility. So in my opinion, in Yasmin's facility, the most important part of the facility was the staff. I mean, Yasmin's staff at the NIH is truly second to none. They've been running their facility for 6 years without a significant loss of germ-free integrity. They've been breeding mice the entire time. I think actually, before I got there, Dr. Sartor just mentioned to me their first set of mice they contaminated, but that was before I got there. So since then, they've been very good. And this is a testament to the quality of the staff, and this is, to me, a testament of what you need. So you need to hire details-oriented people. I don't think it can work if you're just working with a rotating staff of people who are coming in and out of the facility, who are being moved in and out of rooms. The biggest and most important thing was we were able to send our staff from the NIH down to UNC to be trained about how to do this isolator inflation and decontamination. And now Yasmin is going to pay that forward because she is going to let our staff come to the NIH for a couple weeks and be trained. So essentially, it's all all being continued on. And the most important thing is that the staff buys into it, adherence to the SOP. So the staff has to understand that these SOPs have been set up to maintain the mice in a gnotobiotic state, and that if you start playing fast and loose with it, that you're inevitably going to get a contamination, and then all the experiments essentially have to be reproduced, and you have to, if it's a contamination of your breeder stock, you essentially have to start again and email frantically people all over the country. So, and I would like to thank the staff at Chicago, in particular Alexander Travansky, who helped us with our design. He was very generous with his time, which is something he didn't at all have to do. But this is the design of our facility that we hope to sort of break ground on in the very soon in the new year. Basically, what we're going to have at Pitt is 2 separate facilities that run side by side, 2 separate autoclaves, so that if one autoclave goes down and one facility gets contaminated, we'll still have germ-free mice on the other side that we can repopulate our facility with. This is the idea to sort of to give ourselves a fail-safe. The idea would be that essentially these 2 facilities would run as almost as separate universes, and nothing would come across between the 2 rooms. And you would only ever be doing your experiments in one room. Each investigator would be using one room to limit the idea of contamination. So this provides redundancy. The autoclaves you've noticed here are separate in separate spaces, so as to reduce noise stress to the animals, which is an important concern in terms of husbandry and animal welfare. There's a particular HVAC unit in the unit which is positive to the hallway, so we're not going to suck any germs and viruses and parasites out from the hallway into the room. And of course, we have to have compressed air for fogging the isolators. And of course, also as well, the security in the room will be beefed up a little bit. We don't just want anybody coming off the street, but since this is going to be online, we're not going to go into the details of the increased security. We've been looking at 2 types of isolators. We've been largely focusing on these isolators here because, as I mentioned, the users who are potentially going to be using this facility are interested in long-term experiments. So this is the sort of the CDC type vinyl isolator. It has some advantages, which you can breed animals in it. You can house mice for long periods of time, 6 months plus, or in the case of a very famous experiment done by one particular NIH investigator for over a year. The SOP for using these is very well developed. I think everyone in the room who runs a germ-free facility is familiar with these. The disadvantage that we had at the NIH was that we had a very small room. This is a classic NIH problem. You have millions of dollars of equipment, and you have to put it in a closet. So this footprint was a big problem. So actually, Yasmin's lab has purchased one of these units, which we'll talk about in a second. The turning over the isolators, the time to turn them over is a bit of an issue, but you can go faster and faster these days. Breaking them down is labor intensive. And large experiments involving many, so basically each isolator has essentially becomes its own gnotobiotic isolator. So, large experiments involving 30 or more microbiomes, you're going to have to do that, out of the isolator, which is what Dr. Faith was talking about this morning. So one situation is we were talking about is these hermetically sealed cages. So they are efficient. You can run 34 experiments in a small footprint. It's a very short turnover time. From what I've seen in the literature, the max time without contamination from an Israeli group is about 4 to 6 weeks. So you're never going to be able to breed mice long-term, germ-free. I should never say never. Currently, we're not able to breed mice long-term in these isolators. I'm sure Technoplast, if they were here, would disagree with me on saying never. So you'd still need vinyl isolators for your duration. And the big issue, and one of the reasons we're not really going to go with these, is that currently changing the cages is extremely laborious. So changing each cage, in discussions I've had with the staff at University of Alabama, Birmingham, who has 2 of these racks, changing each cage takes about 45 minutes. So if you have 2 racks of these, of 60 cages, that's a significant amount of time for each technician each week to change the cages. So finally, we've been working on sourcing the mice. If you just want to get C57 Block 6 mice, it's about $400 to $500 a mouse with shipping to have them shipped to your facility. This is a great source of B6 mice if you want to breed them. Genetically modified strains, you either have to rederive them in-house, when we talked about the issues of that. For a young facility, it can be a difficult task, but it can be done. One of the good places to source specific knockout mice is UNC. They have a program there where you can essentially purchase them if you can collaboration. Whether we can do reiterations immediately will depend a lot on who we can recruit into the facility, and we're working on that currently. If we can recruit people who have had experience doing this kind of work, we'll probably get it up and running faster. But otherwise, we're going to depend on the gnotobiotic community to get specific knockout or genetic animals. So now I'm going to get away from gnotobiotic animals and talk about the PIT effort to build up the infrastructure, which is also very important if you're going to be starting a gnotobiotic facility. You can't just have germ-free mice and not have any ability to either to grow organisms to put into them. So this is my contribution so far to the facility. This, which was shocking to me, we used to have an anaerobic chamber, but this is currently the only anaerobic chamber at Pitt. It's within my laboratory. This is currently the only way for us to grow communities. But I can say with I'm like going to pat myself on the back. It's not that big a deal. Anyways, so we're now growing communities in an anaerobic chamber, which was something we didn't do last year at Pitt. We have invested enormously in sequencing. We now have there seem to be MySeqs in every building at the University of Pittsburgh. These are the NextSeqs, which sit in the wall behind our anaerobic chamber. So this is all part of one effort to be able to do metagenomic sequencing. We actually now have 3 of these NextSeq instruments, so we can, and they're all at Children's, and it's all part of a combined effort. Of course, you need also bioinformatics expertise, and this has been the one thing that Pitt has been very proactive about doing. This is a non-comprehensive list of the people who are doing this, and in particular, we've just recruited Barbara Mathey and Kelvin Lee, who are world's experts on being able to put together full genomes of bacteria from shotgun sequences of microbiomes, and this is going to be part of a big effort at Pitt to be able to do that kind of metagenomic data. So again, it's not just going to be gnotobiotic mice. The idea is then be able to go in and do the kinds of deep-seek experiments where you can come to metabolic and molecular understandings of the phenotypes that you're seeing in the mice. So this is my final slide. I'm actually going to come in a little bit under time. I guess it helps not to show much data, but I will talk about the welfare of gnotobiotic animals, which is something I have a little bit of experience with. Again, as I mentioned in my time as a postdoc, the gnotobiotic animals do have unique health requirements. I mean, obviously, they live in very specialized circumstances. And again, I just want to underscore the importance of essentially hiring and training the right people. These are the people who handle the animals on a day-to-day basis. At least at the NIH, there is no animal at the NIH that is observed more than Yasmin's germ-free animals. They observe twice a day by the incredible people who work in that facility. The other important thing I would mention is that we're using, basically, from what I can tell, the same SOP we will be using at Pitt, the same SOP we used at the NIH, the same SOP that was using at UAB, which is very similar to what Dr. Chervonsky and Dr. Terrio are doing at the University of Chicago. Adhering to this SOP is not just important for maintaining your mice in a gnotobiotic or germ-free state. It's also tremendously important for the welfare of your mice. I mean, these have not been designed. There's decades of experience in these things, and they haven't been designed just for fun. They actually have a function in both maintaining the mice in a healthy state. And then finally, as I mentioned, education is the most important thing, and educating your community and letting them know what is and what is not doable, and how they're going to have to modify their protocols to do this kind of very important work. So just in closing, I'd like to thank the people who have been involved in this effort at Pitt, in particular the administration there. Yasmin Belkade, who's been tremendously helpful in all of my efforts. Trent Shobe, who spent a lot of time with me both by email and the phone. He's a veterinarian at the University of Alabama, Birmingham. And Sasha Chervonsky, who was very generous in helping us as well with SOPs and trying to design a facility that would have redundancy. This is Children's Hospital, so if you guys are ever in Pittsburgh, I strongly recommend stopping by. It's a great place. And then one more slide, which is if you do come to Pittsburgh and you're interested, or if any of postdocs in your lab, particularly postdocs interested in the microbiome and immunology, we are a growing group. We have 5 positions in immunology that we want to fill over the next 5 to 7 years. So it's a great place. I have nothing bad to say about it. But please just contact Mark Slomchik or Immunology Search at Pitt. We'd love to see you in Pittsburgh. Thanks.